All right, I think it's fantastic that here at the largest manufacturing show in America, we're talking about 3D and additive, because that is the future. That is the future of the 3D additive industry. So it was back on October 2014, HP introduced a new to the world 3D plastic printing technology called multi-jet fusion. And what this has done is it has fundamentally changed the landscape of the 3D industry. It brought two things. It brought speed, quality, and low cost is key to getting into production. And we brought a new open platform approach to our business, where we invited the world to come partner with HP to grow the industry together. And as a result of that, what you're seeing in plastics is the industry is going from prototyping to production. So they say lightning doesn't strike the same spot twice. Today, I'm sharing it does. Yesterday, we introduced Metal Jet. And what we plan to do is take metal 3D printing from a specialized production technology today to mass production. And all this is driven by our mission to change how the world designs and manufactures, or, to say it differently, to lead the next industrial revolution. Now, this is a slide we've been sharing for a couple years now. When you look at the 3D industry, it's relative to the $12 trillion manufacturing industry, a small industry, a small market. Now, it is growing, and it's growing at a CAGR of 25 plus or minus %. But for it to really take off, we have identified 6 factors that without progress against these 6, it just will not reach its potential. The first 3 we say are foundational. The first 3, making progress on these first 3 is key to create the opportunity. The first is product capability. You got to think about what the product needs to do from a consistency, reliability, repeatability, precision. It's competing against technologies like injection molding, CNC machining, investment casting. And so that's the first step that the 3D industry must deliver with their products. The second, broadly, is lower cost of operation. And that's really made up of a couple factors. Is that product capability? It certainly is the material cost used in 3D printing, and finally, it's material selection. And when you make progress against those 3 factors, it starts to unlock the market. Now we say there's 3 factors that can be an accelerator. The first is design for additive. When we think about design for additive, people like to say complexity for free with 3D. And one thing we've learned over the last couple years of really being deeply in this industry, this is probably the most critical step for an industry, for a company to take to really start the additive 3D journey. Second, as we look into the future, we see new supply chains being created. We like to say it's a lot cheaper to ship electrons around the world than physical products. And finally, standards and policies. We see those as potentially accelerators or decelerators, depending on kind of what happens in the landscape. But certainly standards in certain verticals will be key to be established to allow 3D and additive to take off. So, when progress is made against like these 6 factors, especially those first 3, you start seeing the industry shift to production. Now, I love this photo. If you look at there's actually 16 multi-jet fusion 4210s in this factory. They're actually now up to 24 machines. They're running 24/7. And you can think of they're providing a general purpose 3D printing plastic factory. And so what they're doing with their customers is they're allowing their customers to go on this journey from prototyping, because that's where they typically start, to production. And on that journey, then their customers see what is possible. So we're excited to see what's happening in plastics. So that brought us to metals. And one of the questions we get asked a lot is, we were asked a lot, is like, HP, are you going to get into metals? And so when we thought about it, we asked ourselves a question of like, what does it take to get metals into mass production? Because that's really our vision. And so we came up with 3 requirements, is that we had to do 3 things. We have to prove to ourselves that we can do 3 things well before we would get into this industry. First, disruptive technology. We said we need to come and bring kind of an HP unique, because certainly that's key to a business model, but more importantly, a compelling solution. Something that brings a unique contribution to the industry that is sustainable. Second, we said economics, and specifically superior economics, because the only way you're going to get into mass production is to get your economics of your parts down to the point that it can compete with some of the analog alternatives. Third, of course, it's quality. And especially if you're getting into production, there's well-established quality requirements, especially in both plastic and metals, so we have to be able to deliver on those. And it's only after we can check those 3 boxes would we introduce a technology and a product to the marketplace. Before I go any further, we also took a step back and said, let's understand the market. So the first question we asked ourselves is like, what's happening in the market? Where is the volume? And we realized quickly when you start looking at the numbers, the world really runs on metal. But if you look down one level, what you realize, it doesn't run just on metals, it runs on steel and iron. And it really isn't surprising given the performance of that material class, but also the cost of that material class. So, if you're going to get into mass production, you have to be in steel and iron. Now, 3D is in production today, in metals. We see it as a specialized production. You see often using exotic, expensive materials and going after some very high-end applications in aerospace and medical. But it is about picking the right applications. So that brings us to the second consideration, applications. It is ultimately all about what you're doing with the technology, the application, and it's all about what vertical you're serving. So again, we took a step back. We said, let's look at all the verticals out there, let's size them, and understand where the opportunity, where the mass production opportunity is. And we looked at 4 verticals, and we came to a conclusion that there's 3 of interest, primary interest today for us. First, medical equipment. Second, industrial equipment, and we think of this as generators, pumps, industrial pumps. Third, automotive. And automotive is really interesting because currently there is a shift going on in the industry, a shift to things like electric vehicles, EV. And I said earlier, one of the things, the greatest advantage you get with additive or 3D printing is starting at the design phase, taking advantage of the capability that 3D will bring. So it's a unique opportunity for the auto industry, given that they're going through this massive platform shift, and there is a requirement, especially with EV, for lightweighting, to take advantage of 3D. And we'll get a chance to hear from VW here in a bit. And they'll talk about their roadmap. So mass production means medical equipment, industrial equipment, automotive. Okay, we also looked at the industry today. And what we realized is it's a complex landscape. There's lots of production technologies out there. And they're all out there for a reason. They all bring a unique value, and you can see the size of the different technologies. But when we look at that, we want to understand what is our value proposition? What is what we could potentially bring to laser melting, MIMS, press and sinter, machining, investment casting. And so we kind of came to a conclusion, and you can go ahead and you'll be able to study it. When you get to small, complex parts, it's probably an area that we're going to perform very well in. But I've talked about the industry, but ultimately, it is about what you're producing. It's about the part. So we like to always have kind of a poster part, something we kind of ground ourselves in. And this is a roller finger follower. It's for the automotive industry. And so as we develop, we say it's not just about the product, it's about what can we do? What quality can we do? What tolerance can we do? What cost? And so I'm going to be talking about this. But it all starts about how do you make it? So we announced MetalJet yesterday. It is a new 3D metal technology that leverages our 30 years experience in our inkjet Moore's Law. I'm going to share more about the inkjet Moore's Law. You'll leave here with a great appreciation of what that's about. But we really are bringing a new-to-the-world binder jet. Now, binder jetting has existed in the industry for some time, but what we're doing with binder jetting would not be possible without leveraging a couple of key assets that we're bringing that results in the performance, quality, and cost that you'll get with MetalJet. So let's go ahead, let's get inside, and let's see a quick video that explains how the technology works. Let's play the video.
By leveraging and extending HP multi-jet fusion technology for printing 3D plastics, HP MetalJet can propel your business with the most advanced metals 3D printing technology for mass production. Get ready to take on new jobs and unlock new revenue streams. Inside the printer, the carriage features 6 print heads arranged in 2 print bars. Up to 4 different nozzles can print HP binding agent in the same 21 micron grid on the powder bed, providing 4 times nozzle redundancy. The printing process starts by spreading a layer of metal powder. Then, HP binding agent is jetted at precise locations onto the powder bed to define the geometry of single or multiple parts. The energy source helps evaporate liquid components and cure the material. At the end of the process, a high-strength green part can be removed from the powder bed, and the remaining powder can be processed and reused. Out of the printer and after decaking, the part is sintered using an industry-standard sintering solution. HP MetalJet breaks through the productivity, quality, and cost constraints of existing 3D printing technologies for metals. Compared to powder bed fusion, HP MetalJet produces more isotropic grain structure in the sintered part that results in more uniform material properties. Compared to metal injection molding, a time-consuming debinding process is unnecessary with HP MetalJet, taking up to 20 hours out of the workflow. Now you can raise your productivity to new levels and produce complex parts that were simply not possible before in cost-effective, high-volume runs. HP MetalJet. Reinvent opportunities.
Okay, so it gives you a simple overview of how the technology works, and I'm going to go into it in a bit more detail in a moment. But let's go to part economics. And really, when we talk about getting into production, this is one of the necessary capabilities of your solution. So I'm going to go back to the roller finger follower, and you can see in this chart some details up here. We're comparing it to metal injection molding, the cost, selective laser melting, and of course, HP MetalJet. And so we look at a thing we call break-even point. The number of digital production parts you can produce at a cost of less than or equal to the analog compare. In the case of this roller finger, compared to MIM, if you're going to produce 50,000 or fewer of these, based on hard economics, you actually save money using HP MetalJet versus producing via MIM. And of course, versus laser melting, you can see there's an order of magnitude, over an order of magnitude, lower cost of HP MetalJet versus laser melting, 3D laser melting. Now, there's also another part up here, the grasper. This is for the medical industry. It is a smaller part, so really not surprising. The break-even is actually more favorable. It's up to 60,000. And once again, relative to laser melting, it's over an order of magnitude lower cost. So, check the economics. Compelling economics. Okay, that's economics. What about quality? So, what we've done is we actually went and took some of these samples. We produced samples, and we have sent these samples to Inspire, which is an institute in Switzerland, and they went and tested our samples. Now, you can go ahead and see what they analyzed. I'll share a couple things. First thing is we meet all ASTM and ISO standards for stainless steel. So these are standards that are in the industry today for standard production, not 3D standards. So that is critical if you're going to go seamlessly into production. Also, if you look at some of the quotes, they note that it's a homogeneous microstructure. And what the significance of that is you really don't see this in other 3D metal printing technologies. And I love the quotes. You can kind of read them yourself. But I love the quote, leading edge in additive manufacturing. So I've talked about the technology. I've talked about the economics. And I've talked about the quality. But ultimately, you have to deliver this to the customer in some form, a product. So what we're doing here is I'm going to unveil the HP Metal Jet product. It's not quite 6'3". The product, as you can see, is able to produce parts at a productivity rate up to 50 times more productivity, and we measure that in terms of part per unit hour, unit time, than any other binder jet or laser melting system on the market today. Also, I talked about costs. I shared the part cost, but also the product cost. You can see this solution, or this product, will cost below $399,000. And finally, I talked about quality. We just shared some of the results of what comes off of this product, but also you can see we'll start with stainless steel. So that's how we take all this, take the technology and wrap it up in a way that you can go into mass production. So why can we do this? I said it's a binder jetting with some unique capabilities. And there's two keys. I said, we've been doing this, thermal inkjet, for over 30 years. And ultimately, when you look at what we can do with thermal inkjet, we are able to produce very low cost, high resolution nozzles. In fact, we estimate that the cost of a thermal inkjet nozzle is 2 orders of magnitude lower than a piezo nozzle. So we can pack a lot of nozzles. In that product, there's actually 63,000 nozzles. And that is the key to speed, quality, and reliability. And you think about production, reliability is key. And I love what we've done here. I like to think about this as a fault-tolerant design. And so what that means is if you look at each voxel on here, when you go and addressing a voxel can be addressed by 1 of 4 nozzles. And so if a nozzle failed, not a problem. 2 nozzles failed, not a problem. And this fault-tolerant design takes advantage of our high-density, low-cost nozzles in a way that would be very difficult for anybody else. The second thing is chemistry. Now, we've been developing advanced chemistries, again, for 30 years. And about 10 years ago, we introduced to the world a latex chemistry. Actually, a latex chemistry that nobody else in the industry has been able to reproduce. And it turns out this latex binder is fantastic. It creates very strong green parts, and we're able to create these strong green parts using less than 1% by weight of the binder in the green part. And so what that does, as you saw in the video, it eliminates the need for debinding. It allows the production of high-quality parts, and it is very friendly to the sintering process because it's such an open structure, and it's very easy to go through that sintering process. So why? Why is this possible? We all know about Moore's Law. Moore's Law, compute power doubles every 18 months. Well, it turns out we have our own inkjet Moore's Law. We have been doubling the performance of our systems every 18 months since the very first system shipped in 1984, which was 3 years after I joined HP. And the very first system we shipped had 12 nozzles. As I just mentioned, this product is using our Gen 4 platform, 63,000 nozzles, firing up to 500 million drops every second. And this capability, this ability to integrate, is a key to not only low part costs, but low product costs. So now, how are we going to bring this to market? A couple mega trends. Number one, everything as a service is certainly a trend. People like to consume their products on demand. Second, think about getting into production. I mentioned the importance of vertical. And for us to really get into production, it requires great expertise. Expertise that we, as HP, we don't have. And think about getting a part into production. As you know, it requires a very rigorous approach to go through and qualify for production. So we've come up with a multi-year plan. First, we just announced that we'll bring the technology to the customers through our partnership with GKN and Parmatech as a start. GKN is an expert in automotive and industrial. Parmatech is an expert in medical. And what you will see, parts will be available. They will get our product, bring it in, and they will be working with select customers, and they already are, to put those parts into production. In 2019, what will happen is you'll see we will expand the availability. GKN and Parmatech will expand what they're doing with more of their customers. And we'll also make available parts via a metal production service. I'm going to come back and talk. So we can allow broader availability. In 2020, we'll have select product availability for the solution outside of that network. And in 21, we'll have general product availability. And what this approach allows us to do, it allows us to start the production journey. It allows our customers to start the production journey. They can start uploading, getting parts. They can start going through that rigorous qualification process. And as you look into the future, ultimately, there'll be a network that we develop to be able to provide parts services, design services to the world, as well as the ability for others to go buy a solution from HP and bring it in-house. Okay, so that's enough of me, enough about HP. Really what's important is the partners and customers, what they're doing. And so what we'll do is I want to hear from one of our partners. So to start, I'd like to introduce Peter Oberparleiter. Peter is the CEO of GKN Powder Metallurgy. Peter, welcome, Peter.
Very good morning, Stephen.
Hey, good morning, Peter. Come on over. So what do you think?
Really exciting. It's really I was thinking on 10 years ago when we were running around with Nokias, with Motorola's, and we were just thinking we are on the top of technology. And now with tablets, with cell phones, with smartphones, the world has changed. What smartphones did to communication, I think additive is going to do to technology, to manufacturing. And that's really a very, very exciting story. We are very, very keen to be part on as a relatively small player in the market.
Well, you're not that small, Peter.
But
you're being humble. Why don't you talk a little bit about GKN, because I don't consider you guys small.
Let's talk about a bit who we are, who is GKN. We are the world's largest powder metal solution provider, about 1.5 billion turnover globally, present in 10 countries. The only really vertically integrated company in that space. So we have, on one side, powder. We do 300,000 tons a year of powder in two factories. Currently, all additive is just about 1,000 tons of powder. So you see the magnitude of what we are able to do in that space. Then we are number one in the sinter process. We are twice as big as anybody else in that market. 13 million parts a day, which is, just to do the figures, is about 30 parts in each car. So that's what we are, that's what we do. And since a few years, we are working on our baby, which is additive manufacturing. We already give parts to customers on the powder melting, powder bed, and very excited to work with partners like HP and Volkswagen to really move that into the next phase. Getting really, really excited about that.
So Peter, why don't you talk a little bit about HP and GCAN and the partnership, and I'll just say it real quick for us, when we got into this and we did the market study and we looked at who really understood how to do manufacturing production with powder metal, we came up with GCAN. And so we were really happy when they took our phone call, and then we ended up going and establishing a relationship. But why don't you talk about kind of how we work together and how you even work together with somebody like a VW?
Yeah, we got a phone call from HP, and we were excited. We took the plane, flew to Corvallis, sat around the table, and immediately understood that together we could do something great. You know, we can use the printer, put it into production, and finish the parts. We are able to produce through the new technology. And on top of adding on technology, we just felt we would add from a cultural point of view, from how we approach things. Digital is in our heart, so it worked immediately, absolutely fine together. And that was about a year ago, and here we are, presenting this beautiful printer over there.
Well, thanks. So maybe to kind of close it out, talk about, you understand the industry, you understand powder metal, you understand all those different technologies I just talked about earlier. Where do you see 3D additive and specifically metal jet playing in advancing not just your business, but your customers?
Freedom of design, number one. I think we all need to learn. We have already experienced this with our customers because the people there, the engineers, need to understand what could be done through additive manufacturing, and that's a journey. I think that's really, really one of the key points. Weight reduction. We did some examples on motor blocks. We take out 80% of weight. So weight in the vehicle, especially in the electric vehicle, even more of a theme. Time to market. You know, it's something which, if we talk about having individual product, we need to see time to market as a limit today. We don't need any tooling anymore. So we can give the customer parts within weeks, 2 weeks, rather than 8 months. I think that's really the great advantage. And on top of that, it's scalable production. No tools needed. In all the production processes, the conventional production processes, there's a lot of tool cost, and to amortize that, that makes some technologies not viable. Here we don't need any tools anymore. So design freedom, weight reduction, time to market, scalable production, I think are huge advantages which would lead us into the next step of manufacturing.
Well, thank you very much, Peter. So we actually contacted you guys, built the relationship, then you actually brought one of your customers in, VW. So why don't you go ahead and introduce our next guest?
Yeah, I think the final voice is always, or the most important voice is always the voice of the customer. So I'm very, very happy to introduce Martin Gode, Dr. Martin Gode.
Hello,
on
Peter.
Stage here.
Hello,
Good
Stephen.
morning. Good morning.
Good morning.
Martin.
#1 global car manufacturer
In the world. All right. Hey, Peter, thank you very much. Okay, Martin, maybe you could talk a little bit about the relationship that you guys have with GKN and how that works for VW.
Yeah, so GKN and Volkswagen relation based on a very successful business partnership since many years. So we use GKN parts, high quality sinter metal parts in Volkswagen products. For instance, in powertrain, in chassis, and also in interior. So, and we strongly believe the unique ability of GKN competences in metal processing And the unique ability of HP metal jet technology, that provides a window of opportunity to increase competitiveness. Excellent positioning. Yeah, so, and maybe to figure out the motivation of Volkswagen, why we are that happy to be here to partner with you both. So, as you all know, Volkswagen is a leading OEM in the market, and we strongly focus on innovation. Innovation to increase competitiveness. But we also focus on new technologies, introducing advantages. Number one is increased productivity in more than 100 plants worldwide of Volkswagen. Second motivation topic is also to improve our vehicle properties, vehicle functionalities, yeah, to convince our customers and to fulfill also customer needs. Yeah, so, and this is the ultimate third action item. We would like to strengthen the product attractiveness using additive opportunities, yeah, to fulfill more than 10 million customer needs with our entire production volume worldwide. And yeah, so just to conclude, our key strategic topic is to apply 3D metal jet technology to mass production in automotive.
All right, well, you're applying it, and you guys have a very specific plan. Maybe you could walk through how you think about, because it would be real illustrative for others, like how you're going to go through that journey. New technology, you guys have the highest quality standards. How do you kind of go through that journey?
Yeah, so thank you, Stephen. So Volkswagen really strongly intends to make use of the advantages of HP metal jet technology. And so we would like to make use to produce a huge variety of parts, and we would like to make use in really short-term opportunities, mid-term and long-term. Maybe to give you some example. So I have here one part which is more or less a personal key of each customer. So these parts contain a very high quality, valuable key ring metal jet tit.
And this one will have your name on it?
Yes, you can individualize. So this is the first introduction scenarios of this technology. So individualized keys.
Excellent, excellent.
So second example, I'm really proud of, because it's a very famous car in the market since decades. It's a Volkswagen Bulli, and here you see the door of the actual model, the Multivan T6, and we have here a very valuable customized part stating this is the Bulli. That can also be the Bulli of somebody else like Stephen or Peter or each customer here in the room. So first introduction scenario, short-term, customized parts.
Excellent, excellent.
To continue, what is the next step in our agenda? So functionalization of parts in the products. You see here the middle console of our Volkswagen Golf Mark 7, and we have here the gear shift knob, so applied HP metal jet technology with introducing attractive functions to our customers. And furthermore, in mid and long term, we would like to make use of the huge potential of this HP metal jet technology being sintered to entire complete parts. So I have here a very interesting example. So this is also one part that is behind here. It's a so-called mirror mounting. And in the conventional production way, we have to weld together 16 stamped sheet parts. And we did that already in a generative design. And this offers the opportunity, so two main advantages. Of course, less weight, 35% lighter than the previous. And of course, advantage in stiffness, in the function of the part. So this is our midterm and long-term perspective. And so we also have a visionary understanding. So in 3, maybe 5 years, so beyond 2021, 2022, it is a real intention to make use of this technology in structural parts in our platforms. and the platform for conventional powertrains and even more for electric vehicles. And if we succeed in that, we have the advantages that already have been stated. So design freedom. We have the advantage of mass reduction, and we have the advantage of toolless production. And so furthermore, we intend really to substitute metal stem parts or casted parts. That does mean we complement our tooling and production philosophy with additive. And I think this is an ambitious goal, and this goal, we believe, can only be achieved throughout a really strong partnership with HP and with GKN, and Volkswagen is very happy to be part of it.
Fantastic, fantastic. I love it. I love it. Martin, thank you very much. And I love it. The first time I picked this part up, I was so shocked how light it was. And you tell me it's stiffer. That is exactly what 3D and additive is all about. Okay, so fantastic. GKN, VW, super partners, automotive as a vertical. We announced other partners as well yesterday. Velo, an expert in industrial, European expert in industrial equipment. In fact, what they're going to be doing is this is actually a part, you'll be able to see this at the HP booth, for their industrial pump. And what they're doing, and you can actually see a cut up, they're redesigning the features of this impeller blade, which is going to let them improve the performance of their product. And this is something only possible with additive or 3D. We also mentioned Parmatech, a leader in medical. And they are bringing some of their customers who are serving the medical industry, both Primo Medico and OK Industries. So I could talk about it, but let's go ahead and hear from those companies. Let's play the video.
Velo is a technology specialist for pumps and pump systems. We strive for making water accessible for everybody, everywhere, with the highest degree of efficiency.
We're a metal injection molding company, so what we do is create solutions for our customers. And we do that in the form of creating unique metal components to solve their needs.
Primo Medical Group is contract manufacturer and product developer primarily for medical devices. On-demand printing will allow to not take months to get to new products. It allows us to test out new ideas.
HP Metal Jet technology gives us the possibility to be more productive by 50 times. And this new technology is outstanding in comparison to those technologies which we have seen so far on the 3D printing market.
We're in collaboration with HP to develop this amazing 3D printing process, and we see it as really growing our whole manufacturing site and focusing on the high volume, both from the individual part from prototyping to the high volume that our customers are looking for. What you're able to do with the HP Metal Jet technology is take that time into basically you get a model, you feed it to the machine, you get a printed part that day.
For mass production, it is a very important thing to create more than one part in one build-up chamber. And the HP Metal Jet technology allows us to create more parts over each other and next to each other.
With this technology, they can actually explore, and it's going to be a gradual improvement of resolution, speed of output, and further cost reductions.
HP and Parmatech have the same goals for this technology, and that is to introduce a technology that is going to change the world. We want to make a difference.
So what you see is some of our current partners and customers. Now, ultimately, we want to make it simple. We want to make it the technology and the solution available, and for people to be able to test HP Metal Jet. So, and part of the reason for this is we talked about there is a rigorous process that you go through to go into production. So you want to get going on that process as soon as possible. So you also saw, we announced that we'll be putting up a Metal Jet production service. And so this is another way for customers who can start their journey today, already today, they can upload and start learning about what's possible with HP MetalJet. Now, customers can engage now. Now, we'll probably be able to serve parts of those customers in 19, but they can start the journey now. So we want to take all the friction out of the process, make it easy for everybody to start testing and learning about MetalJet. In fact, the site went up yesterday, and we already have parts being uploaded. So that's fantastic to see. So really cool, exciting stuff we just went through. We kind of put together a video that captures the announcements of the day. So let's go ahead and play that video.
Change breeds challenge, but also opportunity. Today's industrial revolution is changing the way we manufacture and design metal parts. Only those who embrace the most advanced digital technology to meet demands will meet opportunity. HP gives you the most advanced metals 3D printing technology for mass production. With HP MetalJet, businesses can drive growth by producing high-quality final metal parts at a low cost per part, unlocking new revenue streams and new applications for outpacing, outproducing, and outthinking competitors. HP MetalJet brings metals 3D printing into mainstream manufacturing. It helps push beyond existing design constraints to create strong, high-performance parts. Achieve complex, functional final metal parts with unmatched speed and consistency to support the industries and innovators that are changing lives. HP is driving transformation with a unique solution to help businesses go further, faster, in a world that demands they never stand still. HP MetalJet technology. Reinvent opportunities.
So, whether it's plastic, 3D plastics, or metal, 3D metals, the 3D additive is in a place today where it can start going into production. So whether you're a designer, a producer, an OEM, the key is you got to start the journey. And the best place to start that journey is to start thinking about how you can design differently. So please come by the HP booth. Go ahead, see parts. We have a lot of parts there. And together, by embracing 3D additive, we, together, can change how the world designs and manufactures. Thank you very much.